Okay. So first you need to know the CDF. So we already discussed about CDF. CDF is f of x. So that's mean minus infinity to x and f of x dx. So you will integrate f of x, the PDF function, from negative infinity up to x with respect to x. So that's the definition of the CDF function, f of x. So now if we want to find the quartile and different percentile, then you can use the CDF function. So how can we use the CDF function? So for example, if we have a symmetric distribution like this, then the second quartile or the median will be the midpoint, right? So that's mean this is the median. So that's mean 50% of the observation are on the left side and 50% of the observations are on the right side. So that's mean this area is the 50% of the total area and the right side area is the 50% of the total area. So that's mean the median will be this point. So this is Q2 second quartile or median. So now we have to find this value. So how can we calculate this value from CDF function? So CDF we already know f of x is equal negative infinity to x. So that's mean the area from negative infinity to x. So if we write, then the Q2 will be okay. So for example, if we write f of x, so that will, for example, this is x. This f of x will give you the area on the left side of x. So that's mean this value of x will give us this area. So now if we want to find Q2, so if we know this area, the shaded region, then we can find the x. So now if we know this area, the area on the left side of Q2, then we can also find the value of Q2, right? Because this x, so if our Q2 is f of x, then this x is our, if this x is our Q2, then this f of x will give us the area on the left side of Q2. And this area is the 50% of the total area. So that means this area is 0.5. So to find Q2, we have to consider f of x is equal 0.5. And f of x is a function of x. Now you will solve this equation for x. And that x will give us the Q2 quartile, second quartile, or the median. Is it clear, or do you have any question? Okay, so let's go over an example. Okay, so we'll go over this example to find the quartile Q3, and we'll also find the second quartile. So now let X denote the amount of time a book 1 2-hour reserve is actually checked out. And suppose the CDF function, so this is the CDF function, and X is the amount of time. So since this is the amount of time, so that's mean this is continuous random variable, and the probability distribution will be continuous probability distribution. So this is our CDF function. F of x is equal x squared over 4. So this is our CDF. And here the value of x is from 0 to 2. So that's mean the function is defined for 0 to 2. That's mean the PDF function f of x is defined for x equals to 0 to 2. So what will be the value of f of x for the other values of x? Otherwise, it will be 0, right? F of x is equals to something. We have to find it from 0 to 2. And for the other values of x, the density function is 0. So that is the definition of the density function. And we already know from section 1. Okay, so now we have the CDF function. And from CDF function, we have to find the probability. So how can we find this probability? CDF will always give us the probability. CDF will always give us the probability where x is less than equal x. So now here in part A, we have to find the probability x less than equal 1. So that's mean this is f of 1, right? From the definition of the CDF function. So f of 1, and we know the function f of x is equal x squared over 4. So what is the value of f of 1? You need to plug in this number in this function. So that's mean x squared. So 1 is squared over 4. So that will be then 1 over 4. Okay, so this is 0.25. Now, if we want to find the next one, part B is, we have to find the probability from 0.5 to 1.5. And we know that 0.5 and 1.5 also between 0 and 2. So we can use the CDF function. So, okay, so before doing this, I need to show you some properties of f of x. Okay, so if we want to find probability between two numbers, then this is actually f of b minus f of a. The value of f at the bigger value of x minus the value of f at the smaller value of x. This one will give you the bigger probability, and this one will give you the smaller probability. So you have to just take the difference of these two probability. So that will give you the probability between two numbers. And if we want to find the probability where x is greater than a, that will be 1 minus probability of x less than equal a. That will be 1 minus f of a. So if you have to find the probability between two numbers, then you have to take the difference of these two probability. And if you want to find the probability where x is greater than some number, then it will be the complement of this probability. So that will be the complement of this one. So that's mean 1 minus probability of x less than equal a. So that will be 1 minus f of a. So now we have probability between two numbers. The numbers are 0.5 and 1.5. So it will be then probability of 0.5 less than equal x 1.5. So that is actually f of 1.5 minus f of 0.5. So we know that f of x is x squared over 4. So we have to take the square of 1.5 divided by 4 minus 0.5 square divided by 4. So if we simplify this one, then it will be 0.50. So that's mean the probability between these two number is 0.5. Okay, so part C is probability where x is greater than some number. So in this case, you have to use complement. So that's mean x 1 minus probability of x less than equal 1.5. So 1 minus f of 1.5. So that's mean 1 minus 1.5 squared over 4, 0.4375. So if you simplify this one, then it will be 0.4375. Okay. Part D is median is the value with 50% below. So that's mean actually if our distribution is like this, then it will be median will give you the value. So if this is our median, then the area on the left side of this number is 50% of the total area. So that's mean 0.5. So now we have to find the median. So how can we find the median? The probability f of x is 0.5, right? because we know that at this value, on the left side of this value, the area is 50% of the total area. So that's mean the area is 0.5. So this f of x is equal 0.5. The f of x is the CDF, which will give you the area on the left side. So now we have to find the x. So we know that f of x is x squared over 4. This is 0.5. So x squared will be 0.5 times 4. So that's mean 2.0. So x will be then plus minus square root of 2, right? Okay, so which value we should take in this case? The plus value or the minus value? Which one we should take? Anyone? Yes, the plus one. Could you please explain the reason? So why we are taking here the positive one, not the negative one? Because the the function only defined from 0 to 2. You're right. So the function is only defined for the positive value, not the negative value. So that's why we are just taking the positive value. So it will be plus square root of 2, which is 1.141 something. Yeah. So 1.4142. So 1.41. So this is the second quartile or median. So part A is f of x is so we have to find the PDF function. So the f of x is the integration of f of x, the small f of x. So the small f of x is the differentiation of the CDF function. So that's mean this f of x, the PDF is f prime x, or the derivative of x. So that's mean d dx x squared over 4. So it will be then 2x over 4. That's mean x over 2, or you can just write 0.5x. So this is the PDF function, f of x, or you can also write f of x as piecewise function. So it will be 0.5x, and this one will be 0. And when x is 0 to 2, and otherwise. So this is the complete PDF function. Okay, so from now for the quiz, I'm not going to give you any specific test on any specific day. So my plan is during the class, during the lecture, I will ask you some question, and you can answer the question now, but you will write down all the questions on a piece of paper. And on the quiz day, I will ask you to turn in maybe on the Blackboard, or maybe I'll ask you to email me. Is it clear?
Actually, so it's only in the solution of the question you're going to give us on the quiz day.
So for yes, so yeah, for quiz, so I will tell you like quiz problems you will consider as quiz. So you will list all the problems, and you will just email me the solution of those problems. Yeah, with the question also. Yeah. Is that answer your question? Okay. Any other question? So that's mean you will not have any formal quiz from now. Maybe during every lecture, I will give you some problem, and which will I consider as quiz. And and you actually in every lecture I will give you some problem. Yeah, and I'll let you know like which problems you will consider for quiz and which problems you won't consider for quiz. Is it clear? I think that way it will be more interactive. Okay. So part F is mu x is equals to expected value of x. So this is from minus infinity to infinity, x f of x dx. So what is the definition of expected value of x? Mu x is the mean, which is the expected value of the random variable. So expected value of x, which is x times f of x dx. And this limit will be negative infinity to infinity. So that's mean the lower limit to upper limit. So in this case, in this problem, the lower limit is 0, the upper limit is 2. So we can just write this is 0 to 2 x, and f of x is, we already calculated it, which is 0.5x times dx. Okay, so now you have to integrate this one. So 0.5 is constant. So you can just write this 0.5 outside the integration. It will be 0 to 2, x times x is x squared dx. So it will be then 0.5 x cubed over 3, and x is from 0 to 2. So now we have to simplify this one. So it will be then 0.5 and 2 cubed over 3 minus 0 cubed over 3. So it will be then 0.5, 8 over 3 minus 0. So it will be then, if you simplify this one, that will be 4 over 3. So that's mean 1.33 or 1.333. Yeah, so this is 1.333. So this is the expected value of x, expected value of the random variable. So now we have to calculate the variance of x. So the variance of x is sigma square, and x means the random variable x. So we have to calculate the sigma square x, which is the formula for the calculation will be expected value of x squared minus.
Are these quiz questions?
Okay. Yes, sure.
Or like, are these quiz questions?
Mm-hmm.
This question you said now, are these quiz questions?
Okay. So I didn't say any question for the quiz right now. I'll let you know.
Mm-hmm.
Sure. So this is the expected value of x squared minus x square of the expected value of x. So we already know the expected value of x, which is 1.33. So now you have to only calculate expected value of x squared. So the expected value of x squared is you will also calculate the expected value of x squared by doing integration. So expected value of x squared is 0 to 2 x squared times f of x, and f of x is, f of x is 0.5 x, right? Yeah, dx. So then it will be 0 to 2, 0.5 x squared times x is x cubed dx. So then it will be 0.5 x to the power 4 over 4, and x is from 0 to 2. So now you have to simplify this one, and finally you will get the variance is 0.2222. So to find the standard deviation, you have to take the square root of this number, because the variance is the square of standard deviation. So standard deviation is the square root of the variance. So that's mean the standard deviation is the square root of this number. Okay. So the last one is Q3 is equals to P75. So we have to find the 75th percentile. So 75th percentile means the area on the left side of X is 75%. So percentile is dividing the value of X or dividing the area into 100 parts, and each part will give you the 1%. So 75th percentile is the 75% of the total area. So if 75th percentile is somewhere here, then the area on the left side will be 0.75. So 0.75. So now we have to find this X. We have to find this value of X. So how can we find this? We know the CDF. So f of X is equal 0.75. So the CDF is X squared over 4, 0.75. So now we have to simplify this one. So then it will be X squared 0.75 times 4. So it will be then 3. So X will be then a square root of 3. We are just taking the positive value. So we are not considering the negative value. Okay, so now try to calculate this probability from 1 to, for this PDF function, try to calculate this probability. And so this is A, and B is, what is the value of f of -3, and what is the, and C is what is the value of f of 7. Okay, so you do not need to solve this one right now. You can do it later, and you should write down all the questions. Okay, so the original function was f of X is equal X squared over 4. So this is the CDF function. And X was from 0 to 2. Okay. Okay, so you do not need to send me the solution right now. You can, I'll ask you maybe next week. Yeah. This week, I will also give you some more problems. So you have to just write down all the problems, and you will turn in all the solutions together. And I'll ask you, I'll let you know how you will.
Are these a quiz question?
Sure.
Are these quiz questions?
So these are the quiz question. These 3 are the quiz question.
Sure. Let me write them down.
So you should just write
write
down. Sorry.
I want to write them down.
Yeah, just write down.
So A, B, and C.
But you do not need to turn in the solution right now. I'll let you know. Okay.
Oh, will you be sending us an email for the exact date in which you want to turn us to turn in the quiz question?
Sorry,
Will you be sending us an email for the exact date that you want us to turn in these quiz questions?
Okay, so to turn in the quiz questions, the date to turn in the quiz question?
Yes.
Yeah, I'll let you know. Yeah. So right now you need to just write down the quiz question.
Please?
You do not need to turn in the solution right now. Maybe next week I'll ask you to email me the solution, or maybe I will ask you to upload the solution on the Blackboard. Okay. So I'll let you know. I will email you about this. Okay.
Could you scroll, please? Oh.
Sorry.
I was just asking for you to scroll up so we could see the question.
Could you please speak a little loud? I couldn't hear you. I'm sorry.
I was just asking if you could scroll up so we could see the question, but you already did. So I was just saying, never mind.
Hmm. If I can, what? I'm sorry. Yeah. Could you please type your question? I'm really sorry. I couldn't clearly hear you.
I think he was just asking if you could scroll up on the page to see the question again. with
Oh,
the
okay.
email.
Okay. Yeah, sure. Yeah. Okay. Thank you.
Okay. Okay, this is also a quiz question. Give me a sec. Could you scroll up? Or could you send me the pages of this?
Yeah,
Could
I'm
you
also
send me
going
the
to
pages?
post this recording, yeah, on YouTube. So you can also
How?
visit there. Yeah. And I'll also send you the link. Okay, so this is the original question. Here you can see. So this is the example. This is the CDF function. So you will use this CDF function to solve those three problems. You will use this CDF function.
Oh, it's you.
Yeah.
Oh, okay.
Okay, so I will also post
Wait,
this.
so
I will also post this annotated lecture on Blackboard, so you can.
but the thing is, the A, B, and C of this is different from the question you gave us for.
No. So this is the
the
original
quiz.
question, and you have to, for the quiz, you have to answer these three questions.
So we should use the example to answer the question. I was like, we should use the example.
Okay, so
to answer
I'll
the
also email
example.
you about this one. Yeah. So, and I'll also email you these questions, or which questions you have to pick up. I will also email you. Okay. And you can also see the recordings later. I will also post the recording on YouTube. Okay, so now I will give you 3 minutes for the attendance. So you have to just type present, okay? And after that, we'll come back to lecture.
Again,
Okay, so now let's start section 4.3, the normal distribution. So this is also continuous probability distribution, and this is the most commonly used continuous probability distribution. So the graph of the normal distribution is bell-shaped, and this distribution is symmetric distribution. So if you look at the shape of the distribution, then you can see this is symmetric distribution. So that's mean if you draw a line on the middle, then you can see this part is the mirror image of this part. So that's mean the distribution is symmetric, and this is bell-shaped distribution. So usually the distribution, normal distribution, is denoted by X, and it is written as mu sigma square. So we use this notation to represent normal distribution. N means normal distribution, and mu means the mean of the distribution, and sigma square is the variance of the distribution. So this mu is mean, and this is variance. And some book also use different notation. They also use N mu sigma, where sigma is the standard deviation. So this is a standard deviation. So usually these two type of notation we use for normal distribution. So, but for the calculation, we shift the distribution and we scale the distribution. And the shifted and scaled distribution is called standard normal distribution. So to calculate the probability, or for the calculation purpose, we actually convert the general normal distribution to a standard normal distribution. And the formula for converting the normal distribution to a standard normal distribution is, this is called z-score. So z is equal x minus mu. So that's mean we subtract the mean from the random variable x. So that's mean we shift the mean to 0. So if you subtract the mean from the values of the random variable, that's mean the mean will be shifted to 0. Then we divide by the standard deviation. So that's mean the standard deviation or variance will become 1. So this is the transformed, or this is the shifted and scaled normal distribution, which is called standard normal distribution. And in this case, the mean is always 0 and 1. So this is very nice property of the normal distribution. So you can shift the distribution and you can scale the distribution. So it's become an standard distribution, which is called the standard normal distribution with mean 0 and standard deviation 1. So for this one, we have the table to calculate the probability and to calculate the z-score. So for any normal distribution, you can standardize the normal distribution in this form, and it will make your calculation very easy. Okay, so sometimes we do not know the mean, the population mean, and we do not know the population standard deviation. So in this case, if you know the sample mean and sample standard deviation, sometimes we also use the sample mean and sample standard deviation to standardize the normal distribution. So that's mean x minus the sample mean is x bar and sample standard deviation is s. So that means z is equal observation minus the mean divided by the standard deviation. Okay, so now we'll go over an example. So this data set is from chapter 1 data set. The 30 randomly chosen students had a mean of 26.7 credit hours. So we selected n randomly students, and the mean is 26.7, and with a standard deviation of 9 hours. So the sigma is 9 hours and mu is 26.7. So student 14 has, okay, so now we have to find and interpret the z-score for student 14 and student 16. Okay, so we know the formula to find the, so here actually this is the sample mean. So this is not mu, this is x bar, and this is the sample standard deviation. So this is S. So we know the formula to find the z-score. Z is equal x minus x bar divided by S in case of sample. And in case of population, we denote it by x minus mu divided by sigma. So student 14 has 51 credit hours. So that means the observation is 51. So this x means observation. So this x means observation minus this x bar means mean divided by standard deviation. Okay. So what the value for the 14 students is 51. So that's mean the observation for in this case is 51 minus the mean is 26.7. So 26.7 divided by the standard deviation, which is 9. So if you simplify this one, that will be 2.7. Okay, for a standard normal deviation, the most of the observation will fall between -3 and 3 if there is no outliers. But if there are some outliers, then maybe you can expect also values outside -3 and 3. But if the data set has no outliers, then most of the observations will fall between -3 and 3. That's mean within 3 standard deviation. Okay, so the z-score is 2.70 for the student 14. So student 16 has 6 credit hours. So that's mean the observation is 6 credit hours. So the z-score will be then 6 minus the mean is 26.7 divided by standard deviation is 9. So that's mean -2.3. So that's mean these students will be on the left side of the mean, right? This is negative value. Okay. That's mean the S-score for student 16 is below the average or below the mean. So here we have an example of normal distribution. So how the normal distribution looks like, so it is bell-shaped and symmetric distribution. So the mean, the middle value is mean. And here the standard deviation is 10. So this is 1 standard deviation. This is 2 standard deviation, and this is 3 standard deviation. So for the normal distribution, within 3 standard deviation, most of the observations will be within 3 standard deviations. Outside 3 standard deviations, there will be maybe 0.1% or something. So 99.99% will be within 3 standard deviations. Okay, so now this is our original distribution, the normal distribution. Then we transformed it to a standard normal distribution. So this is the original distribution with mean 70 and a standard deviation 10. So now we converted it to a standard normal distribution. And this is how the standard normal distribution looks like. The shapes are same. Only difference is the mean here was 70. And for a standard deviation, a standard normal distribution, the mean will be always 0. And the standard deviation was 10 here. Now the standard deviation is 1. And you can see here, most of the observations are between -3 and 3. Okay, so this is the chart for standard normal distribution, and you will be using this chart to find the probability and to find the z-score. So here, this left side column, so this represents the z-score. So this is negative 3.4. And this part also, this first row also represents the second decimal place for z-score. So that's mean how you will read this one. This is actually negative 3.0, sorry, negative 3.40. And this is the corresponding probability, 0.00003. So that's mean from here to here, these values are probability. And the first column, so that's mean this column and this row, the first row for z-score. So that's mean if you know this probability, you can find the corresponding z-score. So the corresponding z-score will be then negative 3 and here 0.02. So that's mean negative 3.02. So so this area is 0.0013 and the corresponding z-score is negative 3.02. So this is the corresponding z-score. Okay. Similarly, if you have the z-score, you can find the probability from this table. So for example, if you want to find the, so this is the normal distribution, and you have the, for example, if you want to find the area of this part. So for example, this value is negative 2. So the z-score is negative 2, you have to find the probability. So that's mean you have to find this area. So negative 2 is, this is negative 2 and 0.00. So that's mean this is the corresponding probability. So 0.0228. So this probability is 0.228. So this table is actually give you the area on the left. So this type of probability is z less than equal z. So that's mean if you know this z-score, and from this table you can find the area on the left side of that z-score. Now the question is, how can we find the area on the right side? So if you want to find this area, if this number is 1, so if you look at this number, that will actually give you this area from the table. But we want to find the area on the right side, and the total area is 1. So if you subtract this area from 1, that will give you the area on the right side. So this is actually similar idea as CDF, because this is CDF. So find the probability for normal distribution. So if you want to find the area below a number, then you have to just look at this z-score. You will convert this one to a standard normal distribution, and you will look at the z-score. And if you want to find the area where x is greater than some number, then you have to use the complement, 1 minus area below found in the table. So, and if you want to find the area between two numbers, then first you will look at this number, find the area, minus look at this number, find the area. So that's mean the big area minus the small area. So from the table, if you look at this number, you will find one area. And if you look at this number, you will find another area. And if you take the difference between the big one and a small one, then you will get the probability in between these two numbers. Okay, so we'll go over some example and it will be more clear to you. So we have an example here. The incomes of trainees at a local mill are normally distributed with mean. So it is given that the distribution is normal distribution, and this is the mean. So that's mean this is mu, and the standard deviation is sigma. So if it is not mentioned in the question that it is the mean is sample mean and the standard deviation is sample standard deviation, you will always consider that the mean is the population mean and the standard deviation is also the population standard deviation. So since it is not mentioned here that it is sample, so that's why we are considering the mean as mu. This is the mean for the population, and standard deviation also sigma. So now in part A, we have to find what is the probability a randomly chosen trainee earn less than $900 a month. So that's mean we are looking for the probability x less than equal or x less than 900. Here x represents the random variable, which is the income. Okay, so in part B, we have to find what is the probability that the randomly chosen trainee earn more than $1,350. So in this is part A. In part B, we have to find probability x greater than 1,350. And in part C, we have to find the income between 950 and 1,200. So that's mean we have to find this income. So this probability. Okay, so let's do the first one. So the first thing is you have to convert it to a standard normal distribution. Okay, the easiest way is use the calculator, but it's better to learn how to use the Z chart or Z table. So first you need to convert it. So x minus mu divided by sigma. So that's mean x is for part A, x is 900. So it will be 900 minus mean is 1100. The standard deviation is 150. So negative 1.33. So now look at the z-score to find the probability. So to find the probability, we will look at negative 1.33. So where negative 1.3, so this is negative 1.3. And the second digit is also 3. So that's mean this is the place where you have to look at. So from here to here and here to here. So that's mean 0.0918. So 0.0918. So the probability is 0.0918. And you can see here the probability is 0.0918. So here we are looking for probability of z less than negative 1.33. So this is 18. Okay, so in part B, we have to first convert it to z-score. So that's mean we have to find the probability where z is greater than 1.67. So that's mean this is 1 minus probability of z less than 1.67. So now we have to look at the table and find the probability for 1.67. Okay, so we do not have the probability for the positive number. So how can we find the probability for the negative? Sorry, for the positive number. We have the probability only for negative number. Since this is symmetric distribution, okay, so we have to find this probability, 1.67. But in this table here, usually in the table, you will also have the positive number. But for this table, you do not have the positive number. So in this case, how can you calculate the probability? So this is negative 1.6. This area and this area are same. So this is the same area, since this is symmetric distribution. So now if you look at negative 1.67, so that will give you this area. But we are looking for this area, 1.67. So that's mean this is the complement of this part actually. Yeah. So from the table, you can find the area, which is then 1 minus, so this is 1 minus 0.9525. So that is actually 0.0475. So this is the area. Do you have any question? Okay, so you can just use the Z table for the learning purpose, but for the test, you can use calculator. Okay. So part C is we have to find a probability between where the income is between 950 and 1200. So first you need to convert these two numbers in a standard normal distribution. So the first number is -1 and the second number is 0.67. So now we have to find the probability between these two numbers. So -1 and 0.67. So this is our X, that's been original distribution. And this is our Z-score or standard normal distribution. So to find this area, first look at this number, -1, and that will give you the area is 0.1587. And if you look at this number at the table, that will give you the area 0.7486. So now subtract the smaller one from the bigger one. So that's mean 0.7486 minus 0.1587. So that's mean 0.7486 minus 0.1587. So that will give you the required area. So, and this probability is 0.5899. So that is the probability. Okay. So from the previous three pairs, we were given the income level and we calculated the probability. So now the question is, if you are given the probability, how can we calculate the income? So that would be actually the reverse way or opposite way. So the part D is, what is the income value that separates the top 10% of earners from the bottom 90%? So that's been the question is, so this is normal distribution. So this is 10%. So this area is 0.1 and this area is 0.9. So you have to find these numbers. So that's meaning you have to find the value of X, where this is 0.1 and this is 0.9. So that's mean, what is the income? So the income which separates the top 10% from the bottom 90%. So actually you are finding the 90th percentile. So to find this one, so you can just look at the table. So this area is 0.9. So to find this one, actually from this table, it is a little tricky to find the area. Okay, so now if we consider the area, 10% area on the left side. So for example, if we consider 10% on the left side, and if we find this number, that will give us the negative number, right? Actually, we are looking at this number because in the table, we have only negative number. We do not have any positive number in the table. Actually, it is better if you have positive and negative number, both numbers on the table, then it is more easier. Since we do not have the positive number, you have to find the bottom 10 percentile. And this number will be same. They are actually same number with different sign, because this is symmetric distribution. So this is 10% area, and this is also 10% area. So that's mean this number and this number are same with different sign. So that's mean if you look at only this 10%, you will get a negative number. So look at 0.1 in the table. Yeah, the area is 0.1. So since area is given, you have to look at somewhere here. So find 0.1 from somewhere here. So this is 0.09, 0.1, 0.09, 0.0951, 0.09, 0.09. Okay, 0.09 and 0.10. So 0.1 is between these two numbers, right? So the corresponding Z-score is then negative 1.2, and here this is 8. So negative 1.2 negative 1.28, and negative 1.29. So the area 0.1 is between negative 1.28 and negative 1.29. So what you can do, you can just take the average of these two numbers. So you can take the average of negative 1.28 and negative 1.29. So that will be negative 1.285. So that means the z-score is negative 1.285. So for this one, the z-score is yes, for this one, the z-score is negative 1.285. So this is the negative number, that's mean this number. So this number will be the same number with positive sign. So it will be 1.285. Okay, but this is the z-score, but we have to find the x value. That's mean we have to find the income. So how can we find the income? So once you know the z-score, you can calculate the x value. So how can we calculate it? So I'll show you how can we calculate it. So we know that z-score is equals to x minus mu divided by sigma. So now if you multiply both sides with sigma, then this one will be canceled out, and we'll have sigma times g is equals to x minus mu. But we are looking for the value of x. So if you add plus mu on both sides, then it will be cancel out this one, then x will be sigma z plus mu. So you know the z-score, you know sigma, you know mu. So you can directly find the x. So here you can see x is equal, mu is 1100 plus sigma is 150 and z is they considered 1.28 and we considered 1.285. That's fine. They are very close. So if you simplify this one, the salary will be 1292. So that means the value of x will be 1292. So is it clear, or do you have any question? So for normal distribution, you might be asked the question in two different ways. One way is you will be given the value of x, you have to calculate the probability. And the other way is you will be given the probability, you have to calculate the value of x. So to calculate the value of x, you have to use this formula. X is equals to mu plus z times sigma, or I can write somewhere else. Yeah, that will be better. So you can use x is equal mu plus z sigma. And to calculate z, this is x minus mu over sigma. Okay, so if you are given the probability or if you are given the area, find the corresponding z-score and plug in the value of z here, and you already know the value of sigma and mu. So plug in the value of mu and sigma and you will find the value of x. Do you have any question? Okay, so part D is when provided the area, we must first find the z-score. That's what I said. So what is the part D? So what is the income that separates out? Okay, so we calculated the z-score, then we calculated the value of x. So part E is what is the income value that separates the bottom 20% of earners from the top 80%. So that's mean actually we are looking for 80th percentile. So bottom 20%. So that's mean this number from the top 80%. So that's mean this is 0.80 and this part is 0.20. So if you look at this area, you will get this number. So you'll get this number. That will be negative something. So this z-score will be negative something. So you will calculate the z-score from here and you know the mu and sigma. So you can easily calculate the value of x. That will be the income. So in this case, the z-score was Yeah, this is 150. Actually, this is not 1.28. Yeah, it should be actually negative 0.84. So this is the typo. Yeah. So that's mean the mu is 1100 plus the z-score is negative 8.84. So the z-score is negative 0.84 times the standard deviation, which is sigma, and the income is then 974. Okay, so that's how you will calculate the z-score when the area is given. And you can also use calculator, and for test it's better to use calculator, because if you use the z table, it will take time, and sometimes using z table is if the idea of calculating probability and z-score from the table is not very clear to you, then it is sometimes little tricky to find the probability and z-score from the table. Okay, so if you have this model, TI model of the calculator, then you can use this command to find the probability. So what is the command? To find the probability, you will use normal CDF. So then, for example, if you want to find the probability x less than 900, the first term was x less than 900. So for calculator, you always need the lower bound and upper bound. So that's mean here we have the upper bound of x, but we do not know the lower bound of x, right? X is less than 900. So we know the maximum value of x is here 900. So what is the minimum value? The infinity, negative infinity, right? Because x can be negative infinity to positive infinity. But we do not know the negative infinity. So that's why we put a big number with negative sign. You do not need to use actually negative 99999. You can also use different number. For example, you can use negative 5555555, or any other big number. So the idea is you will use a negative number, and the number should be a large number. You can use any number with negative sign. So negative 99999, comma, the upper limit is 900. The maximum value of x is 900 here. The second number will be the maximum value of x for this one. And this is mu, mean, and this is sigma, 150. So you have to use this command to find the probability, and that will give you the area below this number. So the area is 0.0912. Is it clear? Okay, so the second one is, it was probability of x greater than 1350. Okay, so what will be the first number? What will be this number in this case? Anyone? So what is the first number in this case? So the first number is the minimum value of x. So x is greater than 1350. So that's mean the minimum x is 1350, right? So the first number is 1350. And second number is the maximum value. So we do not know the maximum value. You can use a very large number with positive sign. So that's mean you can use 99999, or you can use some other number, but very large number. And this is mean, and this is standard deviation. And that will give you the probability where x is greater than 1350. And this probability is 0.0478. And similarly for part C, this is the probability between two numbers. So probability between 950 and 1200. So in this case, both numbers are given. The minimum number and the maximum number are given. So the first number will be the minimum, which is 950. And second will be the maximum, which is 1200. This is mean, this is standard deviation. So that will give us the probability, which is 0.0478. You need to check. I'm not sure whether this is correct or not because they look same, maybe typo. Yeah, or maybe this is correct, but I'm not sure about this result. So part is, what is the income value that separates the top 10% of earners from the bottom 10%? So in this case, the area is given. You have to find the value of X. And to find this, you have to use this command, inverse norm, because you are doing the opposite. In the previous first 3 problems, you were given the value of X, you calculated the probability. Now you know the value of, you know the probability, you have to find the value of X. So you are doing the opposite. So that's why you have to use this command, inverse norm. So first one is the probability. So we are looking for this number, and we know this probability is 90%, so that's been 0.9. So you will always, here you will always give the input as probability, the area on the left side, not the area on the right side. So for example, if you know this area is 0.3 and you want to find this number, you will not insert this number in the calculator, 0.3. You will insert this number, which is 1 minus 0.3. So that's mean you have to insert 0.7. Okay. So in this case, this is 0.9. So the first number is the area, which is 0.9. And this is mean, this is the standard deviation. And the value of X is 1292.23. And in part E, what is the income value that separates the bottom 20%? So that's mean here we have to find this number where this area is 0.20. So you have to find this number. So that's mean the first number is 0.20, which is the area. And the second number is the mean, mu, which is 1100. And this is the standard deviation, 150. So that's mean the value is 973.76. Okay, so that will give you the value of X directly. So from using calculator, you can also find the value of Z. You can also calculate Z score. For Z score, you have to just plug in here 0 and 1. Then that will give you the corresponding Z score for this X. Okay, so do you have any question? Okay, so we have 8 more minutes. So if you have any question, you can ask me because I do not want to start a new section today. So the next one is chapter 4.4, which is the exponential distribution and gamma distribution. And that will be the end of this chapter. And after that, we'll start, maybe in the next class, we'll finish this one and we'll start chapter 5. So this week, I think you have homework due this Friday, right? Okay, so I'll stop here. And if you have any question, you can ask me, okay? Thank you.